Hello friends, you are welcome back. It's another great day here at Ingavcad, and we are here to design foundations. Foundations play a very big role such that they enable us to distribute the loads onto the soil in a process called soil structure interaction. Columns bring the loads to the foundation, to the soil, and these foundations help us to distribute the loads safely to the soil. As we know, the force pressure is equal to the force over area. As we increase the area of the footing, then we are also increasing the pressure, such that the pressure equals the ultimate bearing pressure of the soil, or what we call the self-bearing pressure of the soil. And in this, we can distribute the load safely to the soil. In this, in order to design the foundations, we shall go to the last story, which is story 0, and we shall see our columns. This is column 1, story 1, column 3. This is column 8. As you can see, our columns. What we shall do, we shall click in a column and right click and insert a pad footing. The software will design a pad footing very fast, and it will take us to the tab for the designed concrete pad footing. As you can see, one of the things is that the soil stress, the net bearing capacity, or the maximum soil, has been surpassed. We have 250 newtons, and the one we have is 253. This shows that the base of the column is very small to sustain these loads. So what we do here, it is to increase the length of the pad, maybe to another one, let's say 2,300, 400. As you can see, when we have reduced this, when we have increased this to 300, the thing has already reduced. This shows that as we increase the area of contact of the soil, we reduced the stress. We reduced the stress the load is having from the column. As you can see, now it is safe. Then we also have a check in the reinforcement. What is it? They are saying the reinforcement in the x direction, we provided 2412.74 millimeters squared, but the required was 3010. So how can we come about with this? The reinforcements are too small to counteract these loads. What we shall do, shall come to the rebars and then choose the rebar in the x direction. They are telling us they are 16 of diameter 16 and quantity they are 13. What we shall do here is to reduce the spacing of these bars to maybe 150 and click in another area. As you can see, as we reduce the spacing of the bars, the quantity increased and the area which we got surpassed it. So it's what we have to do here also, to maybe 150. And when we click in another one and we see this is 150, not 250, 150. As you can see, we are providing well bars. These are 217 also in the x direction. As you can see, we can, if we need a top mat, we leave this checked, but if we don't want, we can leave this one unchecked. Then from the rebars, we can go to the geometry also and check the depth of the foundation. Here it is giving us a depth of 1 meter. From the casted concrete, it is 1000 millimeters. This is a very big depth, we can maybe reduce it also to 900. As you can see, when we have reduced the depth, also the reinforcement has reduced. But here it's because we have just changed this. We have to keep reducing this such that the shear at the column face is ticked red. As you can see, the capacity of this column at the shear at the column face, it is 409.5, but for us we have 457.1. In order to make this one okay, we just need to increase the depth to 800. As you can see, it is still failing. We can increase to 900. Now the 900 has passed, but the reinforcement has changed. So we can now go back to rebars and change this spacing again. I think it changes automatically back to 150, and also this to 150, and also this to 150. And as you can see, our footing will be designed. We can generate a report. Or before that, we can see the 3D view of it, as you can see, and then we can right click, and then we see how the thing will be in our footing. As you can see, this is the arrangement of the steel bars in the footing, the pad, as you can see. And then we can now generate a report on the design of this pad. If you want your report to appear in the reports builder, you have to first launch it. If you launch it, it will go in the reports builder, and it's where we can have our all reports summarized. As you can see, they are telling us that it is a pad footing report, giving us the materials, the grade of the steel, and it gives us the lower left corner stress and all the loadings that have occurred in the combinations and in the pad. As you can see, the status, all these have passed, as you can see. So in order to be sure that your footing has passed, all these have to show they are ticked here. So I can close this and also press OK, and it will be designed, as you can see. Now what next is to highlight all these rest of the columns, press Ctrl, highlight also this, and right click, insert a pad footing. As you can see, the software will do the pad footings for us. As we wait, it is designing all the footings. So take a little while as it is designing. So as you can see, Prota is a very easy software to work with in the analysis. And as you can see, it has designed, but only 2 are passing, only 3 are passing. So we press OK, and it will put them here. So the columns which are in red, it means that they have not passed, and the ones which are in gray color have passed, the pad footings. So in order to make these ones pass also, we have to come, double click on it, and look at what is missing. As you can see, the area provided is less than the area required, and so we have to go directly to the rebars and then change the spacing to maybe 150, and also here change it to 150. And as you can see, it is also not sufficient. We can change it to 100 and also to 100, and we click in this. As you can see, now it has passed. Also, we can now press OK, and it will be designed well. It's what we do to the other columns. Double click in it, maybe change the depth, change the depth. As soon as you see the shear at the column face, you have to stop and again increase it until it is not exceeding. So the capacity is now 999.5 and required is 948. We are within the limits. And then now we can go back to the rebars and we change the spacing of the bars to 150. We also go to this 150. Backspace 150. As you can see, also the 150 is not working. We have to change it to 100. And also this one to 100. Click here and it will be complete. If we don't remove the top and bar, the top bars, the top mat, how will it look like? Check in the 3D view and reduce it or increase it, then right click and see how it will be. As you can see, we have the top mat and the bottom mat, and our column is here. So this is it with the design of a pad foundation. We press OK and it will be designed well. Yeah, so this was it with the design of the pad footings. If you have any question, don't hesitate to ask me in the comment section. I will be ready to answer. And if this video has been helpful, don't fail to give us a like, subscribe if you are new, and share to your friends and family so that we can all learn from this. Thank you very much for watching. I remain Gavi. Bye. Let me see you in our next video.